Today's section, 5.5b, is inverse trig functions and their graphs. Here we'll be talking more specifically about the inverse tangent function. So like the sine and cosine functions that are inverses, when the function tangent inverse has a domain, now this one, the domain is all real, so you can get any value, but the range is restricted in between negative pi over 2 and pi over 2, but you can't get those values because remember that tangent's undefined at those points, so you can't have those values. So tangent or inverse tangent of x equals y, that's the same thing as tangent of y equals x, and we can write the inverse tangent as arctan. So example 3, here we want to be able to find the following values. Now remember, for tangent I need to do a little bit more manipulating to help me find what I want. So because it's not just a ratio on the unit circle, it's two ratios divided by each other. Remember, it's sine divided by cosine. Okay? So first you want to remember that the tangent is restricted to the first and the fourth quadrants for the inverse. So I don't care about these. Then remember, like I said, look at the trig function, look at is it positive or negative. So then it's positive. Okay, so that means it's in the first quadrant. So we don't care about the fourth for this one. Then what's your ratio? It's 1. So how would you be able to get a value of 1? There's only 3 values. Remember, you can't be your 0 point because that's a point of 1, 0. So you get 0 there. You can't use this one for tangent because it's undefined. So then from there, now you gotta look at the rest of the points. So you got 1/2 square root of 3 over 2, square root of 2 over 2, and then square root of 3 over 2, 1/2. So what ratio or what point's going to be able to divide itself by itself to get 1? So that would be the pi over 4, right? So you get square root of 2 over 2 divided by square root of 2 over 2. They cancel each other out, leaves you with 1. So it must be pi over 4 for our answer. Okay, now tangent of square root of 3, same thing. I'm going to use the same picture over here. I'll use a different color though. So for inverse tangent of square root of 3, look at my trig function. So restricted to the first and fourth quadrants. Look at positive or negative. It's positive, so it's in the first. And then now I want to try to find a ratio or a division of sine over cosine that gives me square root of 3. But here it can't be pi over 4 because that just gave us 1, right? So we can cross that one out. Okay, then now we need one of these other ones. Now it wasn't going to be 0 because 0 divided by 1 was 0. So it can't be the tangent value of 0 pi. So I got either pi over 6 or pi over 3 to choose from. But, like I always say here, because you have it down to 2, if you pick one and it's wrong, it's going to be the other one. So it doesn't matter which one we really pick unless you really know which one it is. So let's go with pi over 6. Just to test. So remember, it's sine divided by cosine. Here I'll multiply by the reciprocal. The 2's cancel out and left with 1 over square root of 3, which is the same thing as square root of 3 over 3. That is not my ratio, so it is not pi over 6, so it must be pi over 3. If you chose that one first, you would get square root of 3 over 2 over 1/2, multiply by the reciprocal. The 2's cancel out, you're left with square root of 3. So it must be pi over 3 for tangent. Okay? Then here, now I have the inverse tangent of 20. Okay? Is 20 on our unit circle? Nope. So since it's not on the unit circle, you need to plug it into your calculator, which is fine. Not all values are located on the unit circle. So here, inverse tangent of 20, if I plug that into my calculator, remember, your mode needs to be in radians, not degrees, for this. So if I plug that in, I get a value of 1.52. And that would be my answer for that one. Okay. Now let's try some of those composition ones. So with the composition ones, now I've added sine and cosine into those as well, which makes it a little bit more difficult, but not that much difficult. Okay. So sine of 3 pi over 2, let's think about this. So you go around the circle, that's the same thing as 270. So for sine of 3 pi over 2, that ratio is going to be -1. Okay? So now, what angle gives you a ratio of -1 for the inverse of tangent? Okay? So let's go back to our picture. Remember, tangent is our trig function, so it's not the third or the fourth or the second. Then is it positive or negative? It's negative, so it must be in the fourth quadrant, so not in the first. Then I want to be able to pick a ratio that gives me a value of -1. That's got to be this one, because you get square root of 2 over 2, comma negative square root of 2 over 2. Okay? So because you divide those, and then flip them up, that equals -1, right? So, now remember, because you went to the fourth quadrant, you're going in a negative direction to get there, because you can't go around the positive way, because you would be going through restricted areas. So then it must be -pi over 4 for your answer. Okay? Now here they ask for letter B, they ask for inverse tangent of square root of 3 first. Okay? Hint, hint, hint. You just did that one, right? So if you go back, wasn't it pi over 3? Now if you didn't realize that before, you would still do the same thing that we did earlier. So is it positive? Yep, positive. So it's in the first, not the fourth. You would look at your values. You would cross out the 45 or the pi over 4 because it's not going to get you square root of 3. And then you pick one. So let's say we picked pi over 3. So that point is 1/2 comma square root of 3 over 2. Okay. So for pi over 3, multiply by your reciprocal, that gets you square root of 3. So it confirms that inverse tangent of square root of 3 is pi over 3. We can now insert that in. And now just ask, what's cosine of pi over 3? And since you already looked at that point, wasn't it 1/2? And indeed it is. So then that would be the ratio that we want. So remember, with the inverse functions that you're doing, you're looking for an angle measurement. With the regular trig functions, you're looking for a ratio given an angle. Okay? And that's it. Have fun.